Hello, Math 154 students. Today we're covering Section 1B, Propositions and Truth Values. We are going to define propositions and their negations, and we're going to talk about this in words and with symbols that you're going to need to be familiar with. We're going to talk about truth tables, and we will interpret these truth tables, as well as define and make truth tables for converse, inverse, and contrapositives of conditional statements. So a proposition is going to make a claim, either assertion or a denial, that may be true or false. It needs to be in a complete sentence. So let's go ahead and look at some statements and determine if they are propositions or not. Kaisha is sitting in the chair. This is a statement. It could be true or false. So yes, it is a proposition. It is a complete sentence. It makes an assertion. B, I did not take the pen. This is also a proposition. It is a statement. It could be true or false. It is also a complete sentence. Letter C, are you going to the store? This is a question. This is not a proposition. It doesn't assert anything. It's just asking someone, are you going to the store? 3 miles south of here. Letter D is not a proposition. It does not assert anything. It's also not a complete sentence. Letter E, 7 plus 9 equals 12. This one is kind of weird. I know you aren't used to seeing a sentence in this format, but we are going to say, yes, it is a proposition. When I read it verbally, you can hear that it is a complete sentence, even though I know your English teacher would say that that is not how you write a sentence. It can be read as a complete sentence. We're just using symbols instead of words. And even though this is false, we said that propositions could be true or false. So it is still a proposition. It is making an assertion. It happens to be a false assertion, but it is a proposition. So the logical opposite of a proposition is called a negation. And we're going to talk a lot about negations. Negation, it sounds like the word negative, but it doesn't necessarily mean it's the negative version, because if we already started with a negative, then it would become a positive version. So that's why we're saying it's the opposite. So if we had some proposition and we called this proposition P, the negation of that would be not P, which we write with a squiggly. So squiggly P would be not P. Negations are also propositions. They still have the structure of a complete sentence, and they may be true or false. So a proposition is either going to be true or false, as we stated above. If the proposition is true, its negation would be false, and vice versa. We can represent these facts with a truth table. So a truth table is going to outline all of our possible truth values. Our most simple truth table would be our proposition, P. Our proposition is either going to be true or false. If our proposition is true, then the negation of our proposition, not P, would be false. If our proposition is false, then the negation would be true. So again, any proposition has two possible truth values, true or false, which we indicate with T or F. The negation is going to make the opposite claim. And a truth table is a table with a row for each possible set of truth values. So let's go ahead and write the negation of each proposition. Kaisha is sitting in the chair. Well, there is not already a negative in this sentence, so we're going to add a negative. The opposite would be Kaisha is not sitting in the chair. If we had started with Kaisha is not sitting in the chair, it wouldn't make any sense to add the word not, because then you'd have Kaisha is not sitting in the chair, which doesn't make any sense. So that's why I was saying, if it already has a negative in there, then you would take it out to get back to Kaisha is sitting in the chair. Since our original statement was just Kaisha is sitting in the chair, to negate that, we have to add in the not. If our original statement was Kaisha is not sitting in the chair, we would remove the not to get the opposite. 7 plus 9 equals 12. The negation would be 7 plus 9 does not equal 12. So let's negate Amanda is the fastest runner on the team. It would be Amanda is not the fastest runner on the team. So if the negation is false, is Amanda really the fastest runner? So if we're looking at the negation, remembering the negation is Amanda is not the fastest runner. Suppose that is false. It is false that Amanda is not the fastest runner. Therefore, is Amanda really the fastest runner? Yes. If the highlighted statement is false, then she must be the fastest runner. So if the negation is false, then Amanda is the fastest runner. A double negation. So the double negation, not P, must have the same truth value as the original proposition. We can show this fact with a truth table. So we don't really, as I was saying before, we don't really say not. We're just trying to recognize what example 3 was asking was, if the negation is false. Well, if the negation is false, that's the same as saying not P, right? Because our original statement was P. The negation is not P. So saying is the negation false, well, having that negation false would be not P. So that's where that's coming from. Of course, in words, we don't really say, is Amanda not the fastest runner? That doesn't really make any sense. But saying is the negation false is the same as asking, is the original statement true? Example 4, after reviewing data showing an association between low-level radiation and cancer among older workers at the Oak Ridge National Laboratory, a health scientist from the University of North Carolina, Chapel Hill, was asked about the possibility of similar association among young workers at another national laboratory. He was quoted in the Boulder Daily Camera saying, "My opinion is that it's unlikely that there is no association." This is a very confusing statement. So, does the scientist think there is an association between low-level radiation and cancer among younger workers? So here is where we're looking at it. And I said, we don't say not, but occasionally there will be these statements that are made that are designed to be fairly confusing. So in this case, we have unlikely and no association. So together we have a double negation. Since the double negation has the same truth value as the original proposition, we would say the scientist believes that it is likely that there is an association. Example 5, if you ever watch a crime show, you're familiar with the Miranda rights. You have the right to remain silent. These rights stem from a 1966 decision of the U.S. Supreme Court, Miranda versus the state of Arizona, where the court revisited a case in 2000, Dickerson versus the United States. In his majority opinion, Chief Justice William Rehnquist wrote, "Legal principles weigh heavily against overruling Miranda." Based on this statement, did the court support or oppose the original Miranda decision? So again, we're looking at a statement with a double negation. We've got overruling, which would imply opposition to the original decision. And we're arguing against overruling. So we're saying against overruling together, that's a double negation. That means the Miranda decision was upheld. So hopefully we're kind of understanding how these double negations are stated. Obviously they seem a little bit confusing, but we can kind of flesh them out and understand that the double negation is just stating the original.